Okay, hello again. I'm back with my circuit here. This is the electronic control commutator, and as promised, I'm going to explain the functions of these components, and then I'll show you the values of these components, okay? We're going to start with the motor here, the motor L1. L1 is, well, let's go to the parts list down here. L1 is 585 turns of number 30 enameled wire on a 3-inch wood core. It has a DC resistance of 3.6 k ohms. Okay, and there's a magnet that's running around, and that magnet is it's got 4 neodymium magnets, 2 ceramic magnets. Now, as it spins, this being a single wound coil, it will give off a sine wave. So let's start at this end here. If this end is positive and this end is negative, the negative pulse at this end will be grounded by D4, so that provides a reference ground for the rest of the circuit. And the positive voltage here can only go two ways. It goes through D1 to recharge the capacitor, and it also comes up through this line across these components, C4 and R2, and produces a pulse. This is a time constant circuit. It produces a pulse at Q4, which means that Q4 will momentarily be grounded, which will ground out this side of the coil. Okay? When this side gets grounded, there is a negative pulse across this capacitor, which momentarily turns on Q2. If this capacitor is already charged, the charge will now flow through Q2, come across through the diode, and down to this end of the motor. So this end being grounded and this end being charged by the charge on C2 will now energize the coil, and the magnet is given a push. Now, as the magnet rotates by momentum, it reaches a point where the sine wave goes to its peak value, which means that the remaining charge will flow in through D1 and recharge the capacitor, C1. When the sine wave reverses due to the rotation of the magnet, the polarity on the coils reverse. This side is now positive, this is negative. The negative is grounded by D3 for your ground reference. The positive now goes back to recharge C2, and it also comes up through this line, goes across these components, which is also another time constant circuit, which momentarily turns on Q3. That means that this end of the motor now gets grounded, and the grounding will produce a negative pulse across C5, which will trigger this transistor on. The charge on C1 now comes through this transistor across the diode and into this side of the motor. So it reverses the polarity, and the magnet is given another push. At the same time, when the magnet reaches its peak sine wave value, the extra charge will go back into D2 to recharge C2. This unit will find its own triggering point due to the position of the magnet and the output of the coils. This is a self-adjusting, self-triggering, and self-charging circuit, and it will continuously maintain the charge on the two big capacitors, C2 and C1, as long as the magnet continues to run, and there are no restrictions causing sufficient drag to load the system down severely. And of course, this circuit is also good because it eliminates, you can eliminate reed switches, which mechanically can fail, arc, fuse, and so on and so on. Hall sensors are also very good, and they eliminate a lot of these electronic components, but Hall sensors can also be false triggered by stray magnetic fields that shift for no reason, and so on and so on. So I kind of tend to rely on electronics for me, because electronics, they have very specific thresholds. They can only be triggered with certain voltages, at certain points, and so on. And of course, as long as the components stay in good shape, the circuit will continue to run. And the other beauty of this circuit is the fact that these the trigger points required for Q3 and Q4, given that the emitters are grounded, only require a 0.6 volt base voltage. So you can see that the power requirement is not very high. And all in all, this circuit is very good. I've used it time and time again, and I've had no problems with it. The only thing I've had to do was tweak up these values slightly, and aside from that, it works very good. And you're all welcome to try it. Should you have any questions, please don't hesitate to email me, and I will be more than happy to help. I wish everybody luck if you wish to try this circuit. Thank you very much.